I'm here to talk about the framework of the disassembly of an electric vehicle pack for remanufacturing to make second life products. The need for sustainability keeps on increasing as the depletion of the natural resources has been on an exponential increase in the past couple of decades. This has largely impacted the manufacturing industry, which has to deal with the material shortages and still maintain its competitiveness. In the constant loop of material shortages and supply chain issues, it is only fitting that the manufacturing companies form a closed-loop system where they demanufacture or disassemble their end-of-life products and reuse all the parts and the pieces that they can from those products. This will not only help the environment but also save them the cost of manufacturing and time that is spent on a failing supply chain system. It's found for better automation of disassembly of electric vehicles such as the batteries from those cars could be used till the end of their life. It is necessary that electric vehicles be made in such a way that they can either be returned to the automobile company for disassembly or to a third party for automated disassembly and reuse their batteries and other metal obtained from the electric vehicles. This paper is for the disassembly of battery packs from electric vehicles in order to reuse and remanufacture the lithium-ion batteries for the second life application. I will be applying various DFA rules to measure the impact on the time taken for disassembly process. This will also help in estimating the cost of disassembly. The scope of this project is to form a framework for the documentation process or the Honda Clarity Pack disassembly process. Taking inspiration from Boothroyd and Dewhurst method, the connectivity and complexity method, I will be forming a system that would include a series of questions that would allow me to get to a detailed framework for disassembly of a battery pack. This framework will be put to test and updated as and when needed until the end of disassembly experiment. The making of this framework was done using the open source softwares, and concurrent engineering was used, but in a different way. In this paper, the disassembly of a lithium-ion battery pack will be discussed as a case study of how different methods can be combined and arranged in such a manner that it becomes easier to design and optimize a disassembly process to reuse the lithium-ion batteries till the end of their life. We need to focus on the planning aspect of the disassembly and how the pack needs to be positioned before the disassembly commences. After the process, it is necessary to inspect and run tests on the battery modules to check if they are fit to be reused for in their second life applications. Keeping these constraints in mind, an experimental analysis of the disassembly of the battery pack with implementation of Poka-yoke design rules was done. Some of the applicable assembly rules were applied in the context of the disassembly. Rearrangement of the disassembly steps was done to minimize the amount of time it took to disassemble the battery pack. Partial disassembly and complete disassembly were considered. Time taken for the disassembly and the results from both were considered before finalizing the method and the extent of the disassembly that had to be done. Using open source software, a submission form was created that kept track of all the steps of the disassembly along with the tools that were needed for that steps, the kind of joint attachment that was taken apart, or where the part was going to be placed. Was it going to be recycling, reuse, or was it going to be waste, or was it viable enough to be reused again? All of these were made note of. This is one of the videos that we did take while disassembling the Clarity module pack. As you can see, we were disassembling one part of this structure where we were taking out all the plastic constraints and restraints that kept things together in the pack itself. In comparison to the Tesla Model Pack disassembly, it was seen that the Tesla Model 3 had very compact wire harness when compared to the Clarity Pack. It was a lot faster to take out the modules from the Tesla pack, as the entire battery pack was divided into 4 modules instead of 14. All of the battery management system components and wire harnesses were placed in the front of the assembly, making it a lot easier to separate the harness and the modules. The modules of the Tesla pack are quite long and heavy in comparison to the Clarity modules. These are the important differences that changes the way one would disassemble either of the pack. This leads us to the question of how would we optimize the disassembly process if the battery packs from different companies are different. The solution to this is to minimize the time taken to switch tools and work with one tool and use it to disassemble as many parts as possible. Thank you.